the generator, there's different types of generators, okay, and it's important to know what type of generator that you have. In the office, most doctors' offices are going to have the weakest type of generator that there is. Okay, the stronger the generator, the more powerful the X-ray machine. So for generators, you have a single-phase generator. You have a 3-phase 12-pulse. Actually, let me change this to 6-pulse. 3-phase 6-pulse and 3-phase 12-pulse. It's just 3 different types of generators. One is going to be stronger than the other. Okay, so this would be the weakest, and this would be the strongest. So this is pretty much what most doctors' offices have, is a generator with a single-phase generator. And this will be important in a minute because we have a new type of math problem to do based on what type of generator that you have. All right, you're going to calculate what's called the heat units. On page 79, if you skip ahead to that, it shows you an example. Your X-ray tube that contains the anode and the cathode, it can overheat, just like your car could overheat. Okay, if you're ever driving your car and it starts smoking and it overheats, what's the worst thing that could happen? It could explode, like blow up. Well, it won't explode, but part of the engine can actually crack because it gets overheated, and it's going to cost a lot of money to get it fixed. Well, the X-ray machine could do the same thing. If you get it too hot, it could crack open, and then it's not going to work anymore. Okay? So it's important to know how hot your X-ray machine is getting when you take X-rays. For certain X-rays, you can't just do one really quick right after the other one, because you need to give the X-ray machine time to cool down. So what you have to know is how much heat are you producing. It's called calculating heat units. And it's actually pretty easy. Remember the 3 numbers that you put into the machine for the X-ray. You have your MA, your KVP, and your time. So all you have to do is multiply those 3 numbers together, and that tells you the heat units, how hot it's getting. Okay? So let's say, for example, we're going to do an X-ray of the wrist, and it tells you, let's say it tells you to use 50 milliamps, 64 kVp, and 1/10 of a second. Those are our 3 exposure factors. So to calculate the heat units, all you do is multiply those 3 numbers together. So you do the 50 times 64 times 1/10. Alright, so when you multiply these 3 numbers, what I would do is do 50 times 64 and then divided by 10 equals 320.
Yeah.
You just put HUS, heat units. Okay, it's not really degrees, it's just called heat units. Okay. So we know for that X-ray we're producing 320 heat units. Your machine, there will be a maximum amount that you can go. So let's say, for example, it was 5,000 heat units. You just don't want to go over that. Okay. Now, it depends on what type of generator you have. Okay. When it's a single-phase generator, you just multiply the MA times the KVP times the time. If you have this generator, a 3-phase 12-pulse, you're going to multiply your MA, which is 50, times your KVP, which is 64, times the time, which is 1/10, but there's one more number. Okay, it's 1.35. This is a number that represents the strength of that type of generator. So if the problem tells you that you're using a 3-phase 6-pulse generator and you need to calculate the heat units, make sure you also multiply by that last number. That number always stays the same, 1.35.
Even if you're doing single?
No, if you're doing a 3-phase. If you're doing a single phase, it's just the 3 numbers. If it's 3-phase 6-pulse, then you also multiply by 1.35. So if we're using the same numbers, we know that these first 3 are 320, so then just take that times 1.35
432.
equals 432. Okay. Now, if it tells you that it's a 3-phase, because these are going to be word problems, so it'll tell you that it's a single phase, or it's a 3-phase 6-pulse, or 3-phase 12-pulse. If it tells you it's a 3-phase 12-pulse, we're going to change this number. So we're still going to do the 50 MAs times the 64 kVp times the 1/10 times 1.41. So these are numbers you need to memorize, depending on what type of generator that you have. So once again, just to save time, you can say the 320 times 1.41 should equal what?
451.2.
Say that again.
451.2.
Okay, so here's a problem. It says for a chest x-ray, use 150 MA, 74 kVp, 2/20ths of a second, and it's a 3-phase 6-pulse machine. So we know we're going to multiply the MA times the kVp times the time times, what's the other number? 1.35, because it's a 3-phase 6-pulse machine. So we have 150 times 74 times 2/20ths times 1.35. So the best way to do this is in the calculator put 150 times 74 times 2 divided by 20, and that's going to give you a number like 1,100 and something, and then times 1.35. So the answer would be 1498.5 heat units. So just remember, when you're doing the fractions, do the 3 top numbers, the 150 times 74 times 2, and then divide by 20. And then that answer times 1.35. Okay.